All right, no, good evening. I'm going to record hopefully a short tutorial on how to use a calculator to um, do numeric derivatives. And when I say numeric derivatives, meaning it's going to be, the answer you're going to get is a numeric value, not a formula like the way you would do by hand. Anyway, so I'm doing this using the TI-84 uh, emulator. I would probably do the same thing for Casio, but not tonight. All right. Anyway, let's start. So here's my display. This is the keypad on this. And first things first, you probably want to check that your mode is in that you are always in calculus. You're always in radians. So here it is in radians. Okay, so I'm gonna go quit. And there's a couple of ways of finding the derivative or numeric derivative of a function at a particular x value, at a particular x location, in other words. So I'll show you the sort of the simple one and then a more useful one. Okay, I'll start. So the simple one, the very straightforward one, where you literally have one example, one function, and you'll probably not refer to it again, so there's no need to like retype it. So we're gonna go in here in math, and we're going to select down here n numeric derivative. This is number 8, so you can just either scroll down or go right to like plus number 8 and go right to that, and it's waiting for some input from you. So d divided by d, and it's flashing here. It's waiting for an input, and this is typically, we use letter x here as a variable regardless of whether the function is defined in terms of time or in terms of some other variable. That for our purpose, it's always going to be dx, and here it is. Now, if you get into maybe Calc 2 or other courses, there are other variables like theta involved. That has to do with polar coordinates. That's a Calc 2 topic. But for our purpose, it's always going to be x. So right here, I'm going to press this, and notice x appears. In here, the actual function that you're trying to take a derivative of has to go in. So let's pretend, and I really can't write on this, but let's pretend I want, I don't know, x to the third plus, and there's a couple of ways of putting x to the third. I could just say x and either do the caret to the third, and then you advance forward, because if you stay in there, you will be in the exponent. So here, so it's minus, let's say, another way of putting in higher exponents is the following. Let's say I want minus 6x squared. Well, I can literally type xx, and the calculator will know that I'm talking about x times x. This is x squared. Sometimes I prefer this, just it's quicker instead of me taking, like going to the above keys. Anyway, so let's continue. I don't know, plus, let's say 4x, and like plus 8. I don't know, just kind of random function. At this point, I want to scroll out of cursor out of that and go into x equals, and this is where the location at which you want to evaluate your derivative. So as an example, I'll put in, no, I'll put in 2. I don't know what this, I mean, this is cubic function, but yeah, with a dip. Anyway, so at this point, if I hit enter, it'll give me, okay, so this is like, so this is really the derivative there, or the slope of the tangent line is -8. Clearly that would round to -8. If I wanted to change this up to, let's say, a different x value, like I don't have to retype it, I could just go cursor up right from here and kind of grab that. Notice how it's highlighted. On your calculator, it's not going to be highlighted the same color, obviously, but it's going to be highlighted. And then you hit enter, and it brings it down. And now I could edit it. I really can't edit it up when it's up top, because up top it's already that's a completed operation. Anyway, so at this point, if I want a different location, instead of me retyping the function, or if I wanted to like maybe change something about the function, but typically I'm just gonna like at a different value. Let's say at -2. Let's say it's negative. at negative 2 or negative 3. I don't know, that'd be crazy. Okay, enter, and okay, so there is my sort of a quick and dirty way. There's actually nothing bad about it, to if you are looking for a derivative at a particular location or even more than one. Notice how I just could change this up and create a couple of locations at which I'm taking derivative pretty quickly. All right, so I'll leave this idea, and I'm actually gonna uh, introduce a different way of doing it using the graphical approach, well, at least through the graphs. So I'm gonna go graph, and let me try to remember this function approximately. Not maybe I'll try to duplicate it the same. So this is what cube minus 6 squared plus 4x. Oh, I might have to cut this short. Alec, are you coming here? Oh, my kid's coming here. Um, I might have to cut this short. Anyway, so I'll go on the graphical approach. So here's y equals, let me try to remember this again, negative 6 plus 4 plus 8. So minus 6 plus 4 plus 8. So let's do this. So I'm going to put that function in as a graph. So I'll do this. X minus 6xx plus 4x plus 8, I think it was, plus 8. Hit enter. So now, hopefully you know how to graph or how to use a graphing calculator for graphing purposes. You could put more than one function in here. Typically, I have a bunch of functions here. I had to erase them all. Oh. Give me 1 second. Just 1 second. Alec, I'm recording. Go somewhere else if you're going to be talking. Okay. All right. So, sorry. So let's see if this is selected, because notice how this particular thing is blackened here or highlighted. If I did not, well, I'll show you. So graph, and here is the graph of it. Oh, perfect. That's okay. If I have more than one graph on here, and I don't want one of them showing, but the other one's showing, I go into the y equals and basically unhighlight that. And the way I would unhighlight it is I use the cursor to go over that minus or equal sign and then hit enter. And notice how it's taken off now. So if I hit enter at this point, well, it's back to highlighted. But here I'll unhighlight it, and when I go to graph it, notice there's nothing there, because the computer knows it's there, but it's not displaying it. Okay, obviously we want to display it in this case. I'm going to go back and go move my cursor over the equal sign and hit enter. Now it's going to graph, so now I'm going to graph it. Here it is. And what was it at 2? Let's see what is the derivative. If I want to find derivative of this function at x equals 2, happens to be at x-intercept, or at least it appears that way. I'm not saying it is. I would have to. That's going to be another video. How do I find zeros of a function? Anyway, so right now, how to find a derivative? Well, again, there's a couple of ways. But that's sort of this, the simple way from here is using second trace, which really calls up that calculations, or maybe calc. I don't know what calc in this case stands for. So do this, it's giving me options of what to look for, whether it's a value, in other words, particular y value at some x location, or 0 or minimum. But the one I'm interested in right now is number 6, which is dy dx, in other words, derivative at some location. Okay, later on we're going to learn about this, but right now this is number 6, so I can either scroll down to it or select 6, just 6. And now it's waiting for an input from me at a particular x location. Right now it's displaying where the cursor is, but that's and displaying the actual function, the algebraic expression for it. But the moment I do, right now it's waiting for my input on the location of the derivative. So what do we say? At 2, x equals 2, And notice right there, if I press x equals at 2, and it's just, oh, yeah, that location, and I hit enter, yes. And notice how it's gave me the same value as the other method. And of course, that better be the same value. It's the same operation. It's just that this is a graphical approach. And what's nice about this approach, if I want two things at this location, here it's given me a particular y value as well. Oh, so I do know that's a 0 of a function. And its derivative. This is nice. In fact, this is in a lot of cases this is more useful than the other one because this calculates immediately from the graph what is the y value. So let's do that. Let's do this again. Let's duplicate this. I'm gonna what was it? -2 I wanted. Yeah, the previous one was -3. So I'm gonna go in second trace, which calls up calc. And here I'm going to use 6 again, or option 6. And now I'm looking for when x equals, what was it? I think -3. So -3. Enter. And yeah, it was 6. Yeah, I remember that. So even though it's off our window, but as you can see, like that's going to be a pretty steep slope of the tangent line, 67. That's pretty steep. And but what's nice about this approach, it also gives me x and y values to meet like displays. In other words, when x equals -3, the y equals -85, and the derivative is 67. So in some ways, this is a better approach if you need this information. And if all I wanted was strictly what was it, derivative, then I could have used the approach from early on, whatever that was. I forget how to get there. Yeah, I don't want to clear this. I guess I could clear it. Yeah, using this approach, using the end deriv option. And if you recall what that was, I go to math, option 8, and I have to put the data or put the function in again, and there you specify at the bottom there x equals some value. All right, I think I might stop here. There's obviously a lot more to what you can do with graphic calculator, but right now I just want to get a very quick how to take a derivative, both use end derivative option or the graphical approach. Oh, okay, let me clear that. Let me undo this. Okay, clear this. And the graphical approach where you graph it and then you use second calc right there, which is above trace. And there's a bunch of stuff here that's very useful. We'll be using 0 of a function a lot, but not in this video. I'm say intersect. Yeah, we'll be using a lot of this, but right now for the purpose of this video, it's just a derivative. Okay. Okay. Sorry. You know what? I'm gonna extend this video into one more thing I can do here with a using a graphical approach, how to find derivatives, and this might be useful. Well, in certain units, it's going to be very useful. Anyway, so let me go to the y equals. And what I could do is I could define, even though I can't really have this calculator or these calculators, the TI-84 family, it's not a CAS calculator, so it can't really take derivatives algebraically or symbolically. It can only find derivatives at particular locations. What it can do, I could sort of trick it into graphing a derivative function. That I can do on this, and here's how. So here's my function, and I'm going to find its derivative. Although in this case, it's easy enough where I could do it by hand, and just like input this as a new function, which like this is a polynomial. It would be a pretty easy function to put in. But if this was a hard function to do by hand, I would not want to do it by hand if I have this option in front of me. So here's how I'm going to do the second option. So I'm going to using y1 as my base, and y2 is going to be my derivative of my y1. So I'm going to jump over here, y2, and I'm going to say, let me try to recall how it is. Oh, right, right. Yeah, there's two things going on here. First of all, I'm going to bring up math and derive. Right, so it's 8. And so it's bringing this up, in it's yeah, it's bringing up the which looks like and derivative, but I'm going to actually graph it. Over here, you continue with the x, so I'm looking for derivative of what? Well, I could do one of two things. I could literally type this again, all of this, just like that, x to the third, and so on. But I could also trick it into using vars or variables and refer to y1. And how you do that is you use vars, which stands for variables, y variables, so I'm going to cursor across, and this is a function, so it's option 1, and I'm going to say, well, I'm selecting this, right? So it is literally, I'm selecting 1. And notice how it appears, y1. So every time it's going to run this, it's like a little program, it calls up this program. So at this point, I'm going to cursor all across. And here's the kind of trick. Instead of putting a value here, a specific number, I'm going to put letter x. So basically, at which x? At all x's, not a particular location. And now what's going to happen here, if I graph it, which I'm about to notice how both of these are displayed or highlighted, so it's going to graph both of them. So when I go to graph, let me hit enter first. Yeah, so it accepted it. Now graph it. And there's two things. The blue was my original function, and the red one is the derivative of my original function. And it should, well, I don't want to say be familiar. I mean, you're just kind of looking at it. But yeah, if my original was a cubic, in other words, third power, and it's a polynomial, the derivative of that will be a quadratic. And so we'll study this a lot more in detail later on, like the connection between these two. But I just wanted to point that out, as you can do this. But now let's say how is this useful to find the derivative at a particular location? Well, here's how. I'm going to go in and take the graph I'm going to take off the original so that there's less stuff on the screen. I'm going to go over here, take that off, and graph just so this is the derivative. And let's say I want the derivative at x location, what was it, 2 that we were saying before, at x equals 2, right? So let's see. How would I do that? Well, when I'm going to call up we're going to call up calc, now I'm looking at, instead of using this, because this really would be a derivative of a derivative. In other words, this would be like a second derivative of the original function. But if I just want the value of a derivative at a location, well, my graph that I have on the screen right now, 2 seconds ago, is the derivative function. So now, if I want to bring up what's the value of the derivative, I just want the actual y value of my derivative function. So I'm going to say 1. And in this case, if I press 2, I better get back the original answer, which was, I don't know, I don't remember what it was at this moment, but I'll recognize it if I say it. Yeah, -8. Notice how this is, well, it's displaying as if it's a y value, but remember, this graph is a derivative of the previous graph. And notice how this even says that. So y2 is the numeric derivative of y1, which is not displayed here on purpose. I don't like, because otherwise it looks really complicated. But that's another way of finding a numeric derivative. And if I wanted to change, to a different location, I have to, all right, let's go to a different location. So we're gonna the one value, or 1 at we said -2. At -2, it'll be like 67 if I recall. So at -2, enter, and it will be, oh, -3. Sorry. I was going to say that's not a number I recognize, but yeah, I think it was -3. Let's try that again. So this trace 1 for the value, and we want -3, enter, and sure enough, 67. Yeah, way above there. Okay. Maybe I should also do a video on how to set your windows correctly so that like the proper things are displayed. But I think I'll do that when we were doing more graphing specifically of zeros of a function. Right now, for the purposes of this video, I don't want to extend this, how to find these zeros. Anyway, I think that'll be all. And where do I go to turn this off? Okay, I don't remember. Is it this? Yes. Okay. Okay. I will see you in class.